Open RAN is hot. Different vendors have different recipes to cater to this market. Today we look at a vendor that is leveraging the power of GPUs in its RAN architecture. We are talking about Fujitsu. Kaushik Sinha, head of Fujitsu Research India, spoke to Kaustubh Parkhi, principal analyst Insight Research, on this and a variety of related topics. We started by asking about the work done at its India Research Center. Let's listen in.
Good morning, Kaushik San. Thank you for joining us here at Insight Research. In this episode, we would like to learn about Fujitsu Research India, its various initiatives that it has undertaken, and would like to focus specifically on one particular product launch that Fujitsu announced last year, that is in the area of Open RAN. So before we get into the specifics of the Open RAN solution and how Fujitsu Research India has contributed to it, I'd like you to tell us more about what Fujitsu Research India does.
We are organized under, say, 5 strategic research centers. India Center being one of the largest, and here we contribute to all the global strategic topics of research, including AIML, quantum computing, high performance computing, and also a lot of research on the network side. Recently, we have started security along with AIML research as well. And primarily, all these centers coordinate on latest research topics. We do a lot of publications. There are patents rolling out of India Center as well, where we have put a few patents in the wireless technology as well, especially in the mobility area. So this is the center where we started with this, and then a lot of such interesting activities lined up.
In this segment, Kaushik talks about Fujitsu's contribution to the Open RAN solution launched by Fujitsu in combination with NVIDIA and Wind River for NTT DoCoMo last year. Let's listen in.
So I want to now move to the main topic of discussion for today, and that is your product launch in the area of Open RAN, which was announced in February last year, along with I suppose NVIDIA, Wind River, and you conducted it for NTT DoCoMo. I think you launched it in Japan last year. So could you shed some light on what Fujitsu has contributed to this particular initiative?
Yeah, sure. So you're right. Last year we launched in the DoCoMo network, and it is system under deployment scenario at this time. We have long-term relation with the DoCoMo. We have deployed systems in 4G and initial 5G for many years, including say 14 years of history. This particular solution is, as you rightly said, it is also related to not only ORAN, but we use a lot of NVIDIA graphical processing units, GPUs. As you know, those are very high performance acceleration SoCs. And at the same time, we have started with the first release, which was deployed last year. And this year we are doing carrier grade release. It is open to all global customers. Particularly the solution you are talking about in NTT DoCoMo network, it has got very good multi-vendor collaboration, because we have at the lower layer a Wind River platform, cloud platform. We call it WinRCP, and we have a partner NVIDIA for the GPU environment, and Fujitsu has a lot of innovative solutions in DU software, distributed unit software. That is all the resource algorithms on the layer 2 and a lot of layer 3 procedures for RRC and mobility, etc. So this is the solution framework. Apart from this, we also have various other components in ORAN. For example, we have SMO, we have EMS, and all this solution together. So this is the initial deployment where we did trial. We are able to establish initial expectation on quality and then requirements, etc. But we have been developing on this framework, especially focusing on graphical processing units, GPUs, as well as all the advantages which comes with AIML framework along with NVIDIA software framework. So that we want to utilize, because this is a solution which we call Smart RAN, and it has got a lot of upcoming use cases across layers, layer 1, layer 2, layer 3, we plan to utilize in multiple use cases in coming years.
In this segment, Kaushik talks about the centrality of GPUs to Fujitsu's plans for Open RAN solutions. Let's listen in.
It is interesting that you have partnered with NVIDIA for this particular initiative. And when we talk about NVIDIA, invariably the talk of GPU comes into play. And definitely in this particular solution, GPU is a critical component. So my question to you is it that this particular framework that you have developed of the VCU and the VDU, does it work only with GPU accelerated platform or can they work with any COTS?
No, we have been traditionally using COTS servers. They were deployed for years, and although we started with early 4G days, but last 5 years we have deployed system in 5G RAN also in DoCoMo network. Those are COTS systems. Now our roadmap will always consider GPUs because we believe GPU has a lot of advantages, and
Mm-hmm.
it is not only NVIDIA, Marvell, Sina XG. We believe in a lot of openness in our architecture, and we believe in going by ORAN principles. We believe in a lot of multi-vendor innovation and multi-vendor ecosystem. So NVIDIA is definitely one of the prominent partners, and then, as you rightly said, in DoCoMo network, we have trialed and deployed system also along with NVIDIA. But we are working with Marvell as well
Mm-hmm.
as we are working with Sina XG. These are being latest, partners. So it is across GPUs, but we would like to utilize GPUs going forward in our roadmap because of obvious reasons of performance, cost effectiveness, and a lot of enterprise as well as public deployments of RAN. So we feel GPUs are definitely something which will be part of as mandatory solution in our case.
In this segment, let's find out the following. Is Fujitsu Open RAN bound only with NVIDIA GPU? Or is it more universal? Let's listen into Kaushik's insights on this.
Okay, so basically GPUs are essential and it is by design. I mean, that is how you have developed your software in that fashion. So Marvel and Sina XG are also the other two partners that you mentioned in the context of GPU
Yes.
contribution. So in this specific solution, this aerial VRAN that they're using as an intermediary it's a mandatory component. Your solution will not work unless there is an intermediary like that or any other intermediary from any of your other partners, say like Marvel or Sina XG. You need to have that as the intermediary. Okay, so
Mm, Actually, I'll explain briefly if it is okay, because
sure,
this
sure, go ahead.
architecture, yeah, this architecture is important to understand.
Sure.
Openness and this interface level, alignment is very important. And what we have done is, even if we migrate from NVIDIA to any other platform, or for that matter, you might be aware that NVIDIA launched 2 months back Blackwell infrastructure, which is
Mm-hmm.
very powerful compared to A100X and legacy GPU platforms.
Mm-hmm.
Ariel is the software part. It is the SDK. Okay, so
SDK.
Ariel, we have been supporting Ariel. Okay, and lower layer NVIDIA can keep replacing with advanced platforms. We
Okay.
need not do much. We need to do just upgrade library, maybe do some sanity testing, and at the end of it, it will work with the same set of high capacity features like multiple cells and multiple number of UV established calls, etc. So Fujitsu RAN architecture is very well thought out. It has got standard interfaces across components. It means that if lower layer, for example, accelerator platform is changed, then within couple of months' time, based on standard interfaces, we are able to establish working with a new platform, and we are able to achieve similar kind of agreed KPIs and customer requirements. If you see how layer 2 layer 1,
Mm-hmm.
basically because acceleration platform is primarily used for layer 1 processing, which is very processing intensive,
Mm-hmm.
and how these interfaces are designed in RAN products is that we have got standard interface. We call it FAPI interface, and it comes from a small cell forum standards organization. So all
Okay.
the products, including GPUs from NVIDIA, from Marvell, or from Sina XG, as well
Okay.
as upper layer applications, software vendors like any of the incumbent OEMs or from Fujitsu. We follow that specification,
Okay.
SCF specification. So it
So,
is very easy to migrate to next platform in
mhm.
couple of months time with trials and then initial testing.
Okay. So FAPI interface is the common standard for yeah,
Yes.
uh, put forth by SCF, and that is what you follow.
In this segment, let's find out the following. In a GPU fuel solution, how does Fujitsu interact with the orchestrator? Does it need any intermediary? Let's listen into Kaushik's insights on this.
So coming back to this particular, architecture, I had one doubt which I wanted you to, help me with. So your software, does it interact directly with the orchestrator? That I think which is Kubernetes in this case, or do you need the aerial interface to talk to the orchestrator?
Actually, we don't require orchestrator to interface with Ariel, and definitely
No, no, I'm talking about the other way around. Do you need aerial to interface with the orchestrator, or
no, it is not required. Aerial interface, GPU interface is separate
okay,
because it is coming from only, say, GPU vendor. For
okay.
other applications, for example, upper layer 2 processing, layer 3 processing, etc., we use cloud platform,
Mm-hmm.
let it be from, say, WindRiver or from public cloud or from Red Hat, OpenShift, etc. For that, we require Kubernetes and others. For GPU interface, it's not required.
In this segment, Kaushik unravels who owns the 7.2 split in a GPU-based Open RAN solution as architected by Fujitsu. He also talks about smart timing tweaks that result in massive improvement in fronthaul spans. Let's listen in.
This particular ORAN split that we talk about 7.2, have you developed it yourself, or how is it? I mean, what is the for this particular solution? Is the entire split under Fujitsu's domain, or does your GPU partner also have anything to contribute to it?
ORAN 7.2 X, yeah, it is one of the most prominent split being used, and it is splitted as Cat A and Cat B.
Mm-hmm.
Definitely, most of this come from the L1 partners because L1 developer is the one where this fronthaul processing happens, especially from DU point of view,
Mm-hmm.
because Fujitsu has radio units also. So on the radio unit side, we closely contribute towards open fronthaul specification, and radio side definitely we have interface and we understand this interface very fully. But from the DU point of view, because mobile system RAN side is splitted between DU, CU, RU. So
Mm-hmm.
DU point of view, because we are using GPU as partner solution, so
Mm-hmm.
they take care of as 7.2 X split and a lot of upper layer, upper 5 processing. At the same time, we have some innovative solutions also here, by
Mm-hmm.
which, with some changes on the frontal timing,
Mm-hmm.
we can extend this frontal distance from usual 20 to 30 kilometers to very high 60 to 70% high. So we can go up to 50 kilometers. And
Yeah.
yes, and best thing about this solution is that you can use any of the RUs, and with our DU, it will work seamlessly. No changes in RU is required. No need to use only Fujitsu RU. It is based on Open RAN and fronthaul interface specification. Only with our innovative, say, layer 2 timing adjustment, we'll be able to support this kind of
Yeah.
extended solution as well.
In this segment, Kaushik explains in detail how Fujitsu's smart timing tweaks in the latency algorithm result in massive improvement in fronthaul spans. He also lists the target use cases. Let's listen in.
Yeah, would you mind shedding some more light on this timing adjustment that you just spoke about? Because that's a very important consideration. If, from distance increase from 20 kilometers to 50 kilometers will give telcos a lot of flexibility in their network design.
Yes, and as you know, Kaustubh, our Fujitsu RUs are one of the very popular products,
Mm-hmm.
and that was the initial thing. We started collecting information from many of these deployments and what are the pain points, and that's where we started innovating what can help operators reduce a number of DUs, RUs, etc. to cover a specific area. Okay,
Mm-hmm.
specific geography, and that was the initial thought which we started thinking about this. If you know, ORAN fronthaul interface has at least 4 to 5 timing parameters. I think
Mm-hmm.
there are different names, T1 2 3 4 etc.
Mm-hmm.
And by optimizing few of them, we are able to create additional buffer of around 100 to 200 microsecond, and this buffer we utilize to process some additional content on the front hall interface. This is briefly one aspect that we are able to take out from this existing solution. This is customized solution. There is a small logic and algorithm behind it, but this is, I can tell at this time, that those timing parameters on the front hall interface which are related to front hall latency. Latency is the one which defines up to what kilometer you
Mm-hmm.
can seamlessly connect RUs without service getting affected. So this is something where we have put small intelligence, and this is helping us achieve that 60 to 70% longer front haul cables.
Okay, so this works even for 5G radios or
It is
any
for
other,
5G deployment. This is main use case is 5G.
because that there are certain use cases in 5G which are very latency sensitive. So will it work across the board or only for certain use cases within 5G?
See, primarily, if you see, primarily at this time across globe, and it is based on GSMA data,
Mm-hmm.
most of the deployments are MBB deployment, mobile
Correct.
broadband,
Correct.
public deployments,
Yes.
and most of the features should work. I'm not talking about URLLC, where
URL.
latency is important, because that is something which, of course, we have solution, but maybe it is not fully tested along with those use cases. But majority of MBB use cases should be working because we are able to meet those frontal expectations.
Okay. So basically, it's a good launch pad, for operators who don't want to invest too much without testing the technology and getting, some assured returns. Because one of the major dilemmas with 5G is that very few operators are willing to go the full distance as step number one. So, an elegant solution like this, which allows them continuity with the previous, with the existing infrastructure as much as possible without uh, and actually offers them cost saving also. I mean, if you look at it that way, if I'm able to
Yes.
get a decent amount of frontal distance, yeah, I'm actually getting a lot of flexibility, and especially in larger geographical areas where I may not be able to invest that much in my intermediate infrastructure. This particular tweak gives me some flexibility in my network design. So yeah, what you're saying is a very important consideration.
In this segment, Kaushik brings forth the methodologies adopted by Fujitsu in ensuring improvements in operational parameters such as power consumption, as well as in the overall TCO. Let's listen in.
So
Yeah.
one of the major announcements that was made with this particular product launch was very impressive improvements in total cost of ownership, power consumption, and network design utilization metrics. So can you shed some light on how the VCU and VDU have contributed to these enhancements?
Yeah, sure. So, energy efficiency and power consumption are topics which are very common across industry or RAN 3GPP everywhere, especially Fujitsu, because we believe in a lot of concepts like regenerative organizations. What it means typically is we want to give back to community, society, economy, as well as employees' health being
Mm-hmm.
well-being of health, etc. And how we do that is we try to put solutions where energy can be saved, because we believe energy saving is key aspect towards long-term sustainability,
Mm-hmm.
and that's one of the guiding principles where we put a lot of our strategic technology roadmap and thinking. Having said that, there are multiple ways energy efficiency is being handled in our products.
Mm-hmm.
As you know, first of all, we have roadmap to support a lot of ARM based architecture. Okay,
Okay.
and when we think long term ARM based, you already are planning to do some testing on the servers like Supermicro, which are coming from Ampere ARM architecture. So
Mm-hmm.
that is one area where power can be saved, and there are proven numbers, and we talked about this in MWC 2024 as well. As per ARM, there are significant double-digit saving in power saving. Okay, ARM
Okay.
architecture,
Okay.
and it is not the secret. It is well known that ARM works on faster performance and then very quick instruction sets. That's the reason it is called a reduced instruction set.
Right.
That's one aspect. But secondly, you rightly talked about CU software as well. So
Mm.
CU software will be hosted on ARM platforms.
Mhm.
Okay, as well as we have power saving features which can reduce at the RU side configurations based on situation. For example, in 44R kind of configuration, we have
Mm.
two to four transmit paths, and if the requirement does not require four transmit paths, you can reduce to two. So directly all the components in the transmit path, including high power consuming power amplifiers and then receive path LNAs, etc., you can save significant power. So you're saving by CU software configuration, end-to-end RAN solution, RU power. On the server side, where CU software will be hosted, a lot of DU software hosted, you save power. As at the same time, GPUs also come with power saving functionalities. For example, either NVIDIA, Marvel, for that matter, any SoC comes with power saving. So we plan to utilize most of these features in most optimized way to save overall power. So multiple way we are addressing this, and these power saving features we have put together in our product roadmap. At the end of it, operator are going to get good benefit in double digit power saving out of this.
Okay. So power saving is mostly concerned with opex, that is the operational expenditure. What about the capex? I mean, this particular solution, since you are going for a GPU, which many believe is sometimes an overkill for the kind of computing requirement that a base station entails. Would the initial cost be high? And in that case, how does the total cost of ownership work out? Any light you can shed on this?
Yeah. Yes, so there are other SoCs based acceleration also, because it need not always be, for example, GPU based like NVIDIA solution based. How we have positioned our roadmap with these products is that any enterprise deployment, private RAN solution, it is required, then we can propose GPU based, where you gain out of AIML framework, where you have a lot of AIML apps environment also. So that is one deployment where GPU can be used, and also it's a lot of flexible solution. You can use cluster of them. You can use only one of them. Just one of them also. I understand it will cost will at be at say few thousands or say 50,000 plus for one of them. But reality is that it is very high capacity. You can cluster
Okay.
many cells. You can enable a lot of high performance features, and you
Mhm.
can customize it, and you can define slicing. A lot of things you can do. But on the other side, there are other acceleration solution on the SoC. They will not use exactly GPUs, but those are SoC based solution. Many of them are also coming from ARM enabled architecture. So that may be slightly cost effective solution. So we are open to support such also. I think one comes from Marvel as well.
Okay. So great. I mean, basically, it is a combination of using the right platform. In your case, ARM, which gives the power savings on the operational level, and then yeah, of course, there is always a trade-off between the additional features that one gets through GPU and the incremental cost that one has to shell out. Uh,
In this segment, Kaushik places into context where does AI and ML fit into Fujitsu's Open RAN. Kaushik addresses this point on two dimensions. 1. On how AI applications are supported by the Open RAN. And 2. On how AI is helping in the RAN operations. Let's listen in.
One side question is how does all this fit into the context of AI and ML? On two fronts, I wanted to ask you this. One is what AI and ML applications does this particular solutions support? That is one. Second is how much of AI and ML are you able to get into the actual network design itself? So that is these two questions, if you can answer.
Yes, sure. So this solution we are enabling on the uplink power optimization. uplink
Okay.
optimization, we are getting benefits on the using some of the inbuilt AML algorithm. And
Mm-hmm.
because this framework enables to use AML APIs and libraries, etc., from NVIDIA. So that is one intention. At this time, definitely we have tested in-house AML algorithms, and we are seeing significant gain out of it. So
Mm-hmm.
that's one intention on the GPU usage. But
Mm-hmm.
you have rightly very relevant question you asked on the second part, where network design and network planning, we have multiple use cases, and that is where this ORAN SMO kind of solution comes, where
Mm-hmm.
Fujitsu also have ORAN SMO solution. We are developing. In fact, we have demonstrated in last two MWCs. 2023, we developed and demonstrated in MWC one of the use cases where SMO RAP was used, where it was
Okay.
based on little intelligence. But this time we also talked about you know some intelligence AIML algorithms by which root cause analysis for end-to-end network can be
Okay.
reduced significantly, and it's in the order of 30 minutes to 5 minutes, 30 minutes to 10 minutes kind of reduction. So it is very
Okay.
significant. It
Okay.
was well appreciated by operators.
Okay.
And secondly, on the energy saving, traffic optimization, there are a
Mm-hmm.
lot of RAPs we are developing, and all these RAPs work, as you know, on the AIML basic algorithms.
Okay.
And already SMO and ORAN framework is such that it gives a lot of data. There are already framework available on the
Yes.
RAN and as well as core side, 5G core, evolved, say EPS, as well as 5G as 5G system always comes with data analytics and data collection framework. In fact, 3GPP release 18, a lot of framework to collect data and put together in AI ML engine from any other vendor. So all this together, definitely many use cases we are going to support in coming years.
Okay. Do you have your own RIC or this?
Rig solutions, we don't have my own, but we are working on many of these RAPs interfaces, etc.
Okay. So they work with all the leading rigs like Capgemini or
Yes.
the likes. Okay, great. So yeah, I mean, Kaushik-san, it was very nice talking to you and learning about what Fujitsu Research India is doing in the area of Open RAN. And as I can see it, I mean, the solution has a very innovative take on how to harness GPU-based architecture in the area of Open RAN. And as we go ahead and witness, virtual merger of AI, ML, and RAN technologies. This particular framework is probably going to gain mainstream currency moving forward. So, in that context, it was great talking to you and understanding the role that Fujitsu Research is playing and how you see the future going forward and how it is so closely aligned with GPU. So, thank you so much for your time and thank you for talking to Insight Research.
Thank you, Kaustubh. It was good discussion. Thank you very much for having me.
Thank you.